First of all, myself, um, I, I first started in the oil and gas industry as a student in 1977. You can't see my video, so I'm quite old. Uh, and I graduated in 78, and 1982, my brother and I set up the company. So we've got well over 40 years of experience in this type of work. And we started off with optical mechanical theodolites. We've done photogrammetry, and of course, the latest thing with all the laser scanning. So we'll just go on to the slideshow, which is a quick introduction of the company. So you can see, sorry, we to sort of put this this tie point software in context. We have a first time fit philosophy, which means that we try to eliminate all on-site welding and give bolt-up solutions and avoid double handling of pipework and steel, etc. So that can have huge impacts on shutdown, the durations of shutdowns and turnarounds. So we did some trials with Shell in the 80s, and you can see that we've got a lot of experience there on various things. Lots of large companies as clients, $2.5 million contracts, $7.5 million contract in ConocoPhillips, and various locations around the world. So our first hit on this first time fit was on the Amarada Hest Hudson subsea wellheads, and this is in 1995. And there was some key things in this article. This article is from the Oilman, the offshore magazine, which is still, this article is still available online. And Amarada Hess brought this project on 30% under budgets and 2 months ahead of schedule. There's some numbers in the actual figures, which I guess you could probably multiply by 10 on inflation to get a current valuation. And their ideas in finding the least expensive way of carrying it out. The key issue is that the modifications on the turn were carried out without a hitch, and that's part of the work that brought forward the production. And it should be undertaken in all projects. This was the first time we did first time fit, and there's the sort of cost savings that we made for our clients. One more example, putting it in context, this is a more recent example, 2013 in Abu Dhabi, where we created a model from laser scanning. We measured loads of tie points so everything could be bolted up. And we managed to reduce a 3-month full field shutdown to 3 weeks by employing these principles. And I believe the oil production saved was in the order of $184 million for that field. And our dear clients, Total, got an award from ADMA, which we never saw. Anyway, we've got letters from the people on these about what we managed to do, improving safety, reducing handling, removing clashes, and making sure everything fitted the first time. Okay, so as part of that philosophy, to ensure that everything goes offshore or to remote plants, then this piece of software, tie point, basically will measure a tie point accurately from a point cloud, so that we can determine if there are any flange angles, any significant flange angles, any significant bolt rotations, and we can also get precise measurements between flanges, which are probably plus or minus a millimeter, depending on the quality of your scan data. So we've had examples in the North Sea sector where we're hosting a database. Client has a broken flow line spool which is leaking. They identify the spool to us in the online database with some coordinates, and within a matter of hours, we've found the spool, measured the tie points, and they're delivering a fabrication drawing to the fabricators. So in the old days, somebody had to go offshore, measure it up, etc., etc. Days of production lost on a wellhead, and with this software, we're cutting that down to a matter of however long it takes to fabricate the full spool and get it offshore. So again, cost savings. So we'll finish with the PowerPoint, and now we'll go on to the, I'll just stop sharing for a moment. And where's my taskbar gone? There we go. I'll put up AutoCAD. So can everybody see the AutoCAD screen now? I'll just share the screen again. There we go. Share the screen. Yep. Nice blank AutoCAD drawing. We'll just fire up tie point. Now, at the moment, this is an external app. It's not within. It's not an add-on to AutoCAD. That might cause a problem for major companies with their IT department, but we do hope to port it into AutoCAD as an add-on, maybe in nine months to a year. So at the startup, this version that I'm showing you today is actually at beta testing stage. We previously were working with Aviva Point Cloud Manager in its old form, LFM. That's the one that we're using to do all our tie point measurements at the moment, but clearly Recap is rapidly taking over as the preferred point cloud manager. So we get a choice of here. You can then browse for models, use active models, or whatever. Now, the interface is deliberately designed to be small because it may be that some survey companies might want to use this software on site on a laptop. So we've deliberately designed the interface to be pretty small. So the first thing we'll do, we've got a toolbar up here for recap. So we can just attach a recap file. Okay, try and open that. I think I've accidentally put it in here. There we go. Okay, so there we've got a recap. Now, the problem with recap files is that, like any other object in AutoCAD, you can move them. But what we've done is when you load it using the app, or whenever the app runs, it will lock the point cloud files because so you cannot move them accidentally. Yeah. But if you're working with very small areas of the point cloud, then you could accidentally move them when you were moving something else. So we've got a few utilities. You can switch it on and off. We've also put all the point clouds on one layer called tie points, so you can switch them off that way as well. We've got our own crop routine, which is a safe crop, which sort of mimics AutoCAD's cropping. But what it does is it unlocks the point cloud, crops it, and then locks it back up again, so that so you're perfectly safe when you're using this. egg from that.
When
Yeah.
you see the project, the point cloud that's locked, are you using the built-in AutoCAD lock layer? Or is it,
Yeah.
oh, okay. So you can unlock it manually if you go into the layer controls and you,
Well, yes. I mean, you
okay.
can you can select the point cloud as you would normally. Um, hold on a second. Here we go. Uh, so we'll just clear that. We'll just clear that current crop, right? So we can see again. But yes, I mean, you can basically pick that and go to the properties if it will show, and you can see it's
Yeah,
locked.
okay.
So
Yeah.
so if you wanted, you can unlock it. We've also got some options that you can, trying to keep everything close to the interface here. You can unlock the cloud here if you want to. So
Yeah. But
you
does the software have a feature that you can crop while the software is locked?
yes, that's right. Because if that's what I just showed you. If I click this option here, at the moment I'm just using box, but I can simply do that. Oh dear. All right. And hold on a second. Got to hit escape. We'll have to clear the current crop. That's the trouble with doing things online, but
Yeah.
doing them live. But yeah, you saw at the start there what that when I cropped it, it was a safe crop. I put in a box, it cropped it to that, and then it locked it again. Okay, so we can also do things like change a color, and if you want to, you can change it to any color you like. Um, Normally, for measuring, you're better in grayscale intensity. It shows the edges much better. So we'd normally be working in grayscale intensity. Okay, now we could crop the cloud and try and find, but we've got a little find tool here so that you've got options. If you know the location, you can punch that in, or you can always just pick the point cloud. So we can pick here and it puts up a box. And you can then edit that box as you wish. We've made the grips bigger so it's easier to do it. And we can also, you can now also just rotate the box if you want. So I'll just try and get this a little bit neat. Let's do a crop to the box. Yeah, yeah. I'm sorry. I'm going to have to cancel and reload that point cloud because it's something happened when we're doing the crop. So what we'll do is we'll just unlock it, and we'll just delete it. And we'll just do it again. Okay, so we'll go to find the tie point, pick a point. We can reduce the size of that, redraw the box, and then best go into plan view. I think we can just stretch it out a bit here, crop it to the box. So this is just basically to get your focus on the area of interest. Normally we would recommend trying to cut out the flange, which is not the tie point flange, particularly for bolt rotations and the such, but that's a matter of choice. And I'll just do it from a side view, make sure we've got everything there, crop to box. Okay, so now we've got this cropped. We can save this crop. So we can put in, we'll call this tie point 2B. And we'll save that crop state. And then that means at any time you can come back and you can restore that crop. So if anybody was doing quality control or checking somebody's work, it saves all that time cropping it. Okay, first thing then is to measure the flange. We've got several options, so you can use the recap cylinder fit. You can use surveyed circles. You can use various other objects. This is the normal way that we are doing it at the moment. You have to tell it whether it's a plan and elevation flange or an easting and northing if the flange was vertical. So in this case, it's plan and elevation. First thing to do is to then, okay, hold on, press the wrong one. We measure the horizontal angle. So it puts you in a horizontal view. You can see how you can see the edges reasonably well now. So we quickly measure that. You don't need to be too accurate at this stage because later on we'll be able to adjust what we're doing. Now, normally we've got a nice vertical view now. You'd normally go back and measure the horizontal one more time because every time it's updating the views to match what you've been measuring. So it's then putting up the angles that have been measured here. So we're happy with that. So we hit OK, and the next thing to do is to measure a circle to position it. So we draw a circle, we click the classic AutoCAD 3 points, and there we've got a circle. You can redraw it if you want. If not, you can just press proceed. Next thing to do is we need to tell it where the face of the flange is. So we can zoom in here, pick the face of the flange, and it's on the valve, so we'll put it somewhere about there. I can refine the position if I'm not happy with it. So now we've now got enough information to actually draw the flange. So we get a split screen just to assist your visualization. There's the circle, now match the flange, and we just have to tell it what kind of flange it is. So weld neck raised face, let's try a 300 pound. We're not sure of the nominal bore. So this will eventually fill up with the design sizes once you tell it what it is. But we can click on any of these and we can measure any of the values if you're not certain of what kind of flange it is. Obviously, if you've got an isometric, that's telling me it's a 16 inch. So you can now say 16 inch. But if you've got an isometric, you could just fill this out by yourself. So you now see that it's come up with the design values for that, which you can compare to any measured values if you want. So we'll just draw that, pick the gasket size, and it's quite clearly it's not a 300 pound. So we'll just expand this again, change it to 150 and redraw. And there we can see that's a pretty good fit. Don't worry about it being off there because we'll have the opportunity to adjust that later. Now we can flip it because that side we want is a tie point, and also on certain flanges you can alter the face so that you could have raise face plus, for example, raise face minus, if you like, but we'll just stick with raise face in this case. So we're quite happy with that. So we hit OK. It's now just calculating various viewports. Next step, you'll see there's an arrow going down here suggesting what your next step should be. So the next thing is to adjust the flange. So we've now split the screen into three views. So this is a view onto the face of the flange. This is a plan view, and this is an elevation view. And you can see from all the arrows round about here and the tilting arrows, we can shift this now to suit the point cloud. So if we zoom in on this point, then you can see that we're shifting it over, and I happen to know that that's about right from my pre-demo tests, that should now fit pretty neatly on the other side, which it does. And we should adjust this, but that looks like it's quite a good fit. So we're quite happy with the plan view, so we can just play about with the AutoCAD screen, have a look in this view. You can see now that we've got a much better fit. There are a few tools in here so that we can put in a pair of flanges, which helps you to visualize it. We can change the flange color to help you to visualize it. And we can change the line weight so that it's thicker if you've got problems with your point cloud. And you can also do things like change the face of both flanges, and you can also change the AutoCAD background color. All of this is just to help you to do the visualization. Now, I'm going to just use a recap option here. The point size, we're going to increase it to 2, just so it's more visible. At the moment, I'm not too sure about where the facius flange should be in this direction, but I'm setting it to be, so this is on the back of the flange, and if we can go down here, it's pretty good, but I could, using the arrows over here, for example, you can see that I can tip the flange in the horizontal to get a best fit. As soon as you tip it in the horizontal, you'll find that your representation here is no longer correct, so you have to realign the views. So it recalculates the views for you, and then you can go on to the vertical alignment, which is pretty much the same as the horizontal. I know that if we go in here, you can see we're getting a much better idea of where the face of the flange is. So we can scoot this over so that the face of our flange is in this groove here. Now, simply for the speed of presentation, we can tip this flange to suit as well in a similar manner. Once we're happy with all of that, we can then just hit OK. Sorry, yeah, we're back. Oh, not sure frozen. Never mind. Anyway, there we go. We've got our flange on the point cloud, and yeah, you can see it's quite nicely fitting there. The next thing to do is to measure the bolts. A bit similar to the last screen, and what we can do is usually having the bolts on in this type of flange gives you a better idea of what's happening. And similar to the last screen, we can just rotate the bolt hole rotation. That's going in 0.5 mil, so I'll increase it a little bit so you can see that it's rotating the whole thing clockwise, whatever. We can reset it. I think in this case it's a couple of mil. Best ones to check are here and here on a vertical flange. If you want, you can also, if it's one hole top dead center, we can just press this button and it will report it to that. So once you're happy with the bolt hole rotation, then we just hit OK. And now the last thing we have to do is to annotate this. First thing we have to do is to set the isometric view. So simply click the direction of the client's isometric view, and it puts you back into that view, and it removes or hides the point cloud just for the sake of clarity. So the first thing we're going to do is to draw the flange angles. Now, our horizontal flange angle isn't square to grid, it's 275, so it's wanting a design angle. So we have to put in a design angle, which I'm guessing was 275 degrees, and then it's now reported, those angles. This here will then position the text, and if you want, we can flip where it's actually showing the horizontal angle. We can also, this is using symbols. If we want, we could change that to a written amount. Okay, so let's change horizontal, vertical, flip that, and we'll put that middle left. And we can also stretch that in and out until we're happy with the positioning of it. Then move on to the bolts. We can draw them. In this case, we can move them all around about, and we can also scale it and offset the position. Once we're happy with that, onto the tag. Now it's looking for an ID, so TP2B. Okay, in goes the tag, 16-inch 100-pound weld neck raise face with the coordinates. Once again, we can move that tag roundabout if you've got lots of flanges in there, and you can scale that and offset it to suit whatever you want. And basically, done. And that's the tie point measured. Now, we will be having tools whereby we can export this to a drawing. We can export it to an Excel spreadsheet, notepad, or clipboard. Sorry. Was there a question?
I noticed when we were looking on the side view,
Yep.
because there's a certain amount of scanner noise, and when you do, okay, well, you provide this service, but you're also selling the software, sorry.
Yes.
So do you scan always at the same high resolution for your typos, or does it depend on what you think you need for accuracy? Is it always the same scan settings?
It would depend on the situation. I mean, if we were doing an individual spool, then actually you're normally so close to it. Or you could be doing a spool in a workshop, for example, and a couple of scans, and you've got the job done. But in the majority of our cases, like the example I just showed you, they're replacing some of the pipework on that bridge. And we have to take hundreds upon hundreds of scans. So we normally scan at high resolution, standard quality. If necessary, or if the surveyor thought it was appropriate, we might do higher resolution or lower resolution, depending on the situation. But in general, you will always get this spread of points that you're seeing there. It depends totally on the condition of the item that you're surveying. These ones are covered in sea salt with flaky paint.
Yeah.
Okay, so let's go back to the client ISO view. So in terms of product, I've sort of prepared. This is one that we've done for a client where this spool is being replaced because they want to connect other it's brownfield modification, and this connection down here has been added, as it were, to the existing spool. So we've surveyed a couple of tie points. We've also modelled relevant stuff like a pipe support and a potential clash. Yeah, and this then becomes a red line markup of because the client has existing isometrics. So you can see that we've added on here all the information showing on the spool. Unfortunately, as is almost normal, that the pipework is not in square. There's an 18mm offset, etc. So what we would not in the plan view, so what we would normally view is we can then rotate the spool locally and eliminate some of the flange angles, reduce some of the bolt rotations, and get rid of that offset. So that then, with the model rotated, we're then able to give a much simpler red line markup for fabrication, just by inspecting the data. And you can see there's now, we've only got one flange angle here of note. This bolt hole rotation is reduced, and up here, one flange angle and a smaller bolt rotation as well, and our 18mm offset has gone. So after you've measured all your tie points, it's worthwhile spending some time looking at it and seeing if you can simplify it for fabrication. So really, people, that's about it. I'll just go back to our model with tie point, and I'm open for any questions.
Well, I sent a couple of messages to you in the chat.
Okay.
It's just asking you if you are aware of certainly have you posted anything in the laser scanning forum about this?
No, no, not normally.
Okay.
To be honest, until about a year ago, we decided we would look at putting this out commercially. Actually, because of the COVID hangover and lack of other work, it looked like it would earn us some money, some cash by putting it out commercially. So that's why we've developed this recap version, is so we can release it commercially. It's at beta testing. Once it's gone through that, then we would be advertising it all over.
Yeah, the other thing I mentioned in the chat about Dennis Gorovchuk, and I don't know if I don't know what your tech people are like, but he does point cloud cropping software. We interviewed him. SPED interviewed him last year, and I don't know if he could be of any assistance to you.
Yes, yes, I'm open to any introductions. I think I didn't really fully show it because we're looking at the tie point. I just showed you the routine so you can quickly isolate the tie point that you're interested in. But if I just go in a top view here, our cropping facilities include, so there's an option here to do H. So I can simply go like this, draws a line, and I can pick that side, and it chops the point cloud. Yeah.
Right.
Um, I
Dennis has a way that you can lock the point cloud, but also crop it.
Yes. It, do you know we're not using the internal AutoCAD
Okay,
routines in a significant way, and there's a lot more available within if you link in using what's called object arcs,
okay,
and that might be possible. But this cropping that we use, that point cloud is at the moment it's still locked. But what we're doing is unlocking, as I said, and cropping it and then locking it back up again. So we've got those utilities, but of course, do you know, eventually AutoCAD might realize that it's a bit silly allowing your point cloud to move all over the place if you don't really want it to. So you should be able to crop it without unlocking it. I'm
yeah,
sure Autodesk will eventually catch on to that idea.
yeah. I've done that many times, and then you wonder what's going on. It was okay. It's because you don't notice you're focused intently on something, and you forget to lock the point cloud, and then next thing you know, your point cloud is moved.
Yeah. Well, I mean, fortunately, you can always go back to the properties, and you can reset its
Yeah,
position. You can reset its position to 0, 0 or whatever it was. But if you've done a lot of work with it shifted, it's painful.
yes.
I've typed in the chat a couple of questions, but I'll go ahead and speak the question, and but I've tried to write it as well. Most of these scans are done in a hot plant that is probably hot operating conditions, and that means the pipe is moved and under load and so on. And then after you get the operating position, you're always faced with a challenge of, okay, now I have to put it in a design model and because the installation will be done when the plant is cold, usually, uh, and I have to put that in a design model, a stress model, and then determine the actual position of the plant when cold, when installation would take place. So, what are you finding that people do? Is this once they, by analysis, get this cold position, this construction position? What do you find they do about entering the model in their entering the tie point model, tie point into their 3D model? Are they doing this manually? After the analysis is done, or is there some way of importing this? I mean, because this addresses a huge area of preparing the general arrangement for actual add-on design, finding the actual tie point in different conditions. Are you going to install hot? Are you going to do a hot tap? Are you going to do a cold construction? Finding that position. This could be a terrific tool, but there's an possible analysis step before you get done. What methodologies are there to import this into 3D model? Is it all manually positioned, or is it done? I mean, do you put it in the scan? I mean, not sure. It seems to me there's an analysis step in here, and then an import step of an analyzed predicted position.
Yeah, I mean, obviously, well, I'm in Abu Dhabi. Never mind the plant, the actual pipework, particularly flow lines, etc., might be extremely hot. But even air temperature, I mean, we're running at between 50 and 60 in the sun at the moment. So it is always an issue. Um, what happens to those tie point when the plant cools? Uh, I have not got a lot of ideas. If it's a small tie-in spool such as this example here, then even considerable temperature difference should not have too much of an effect on the dimensions. Even considerable temperature differences, because it's such a short dimension. But when they cool the plant, does the pipework pull all the way along? I know that there's like big expansion loops in some of this pipework further along the plant. It's very difficult to predict where that would end up. The best you could do is perhaps scale the whole thing according to what you think the temperature will be when you install it. I'm a surveyor. We do a lot of projects where they're building stuff in Singapore, installing it in the North Sea, and we normally scale it all for 20 degrees C. We measure the surface temperature when it's being built, and then everything's reduced to 20 C for installation purposes. So that's the only sort of thing that we can do in terms of temperature and pressure. What as far as I mean, I know, I've been offshore when they've been fitting this stuff. When we first started in the company, I was in fab shops bending these pipe spools to make them to the right sizes and to get the flange angles, by weld capping procedures and all the rest of it. Our philosophy on pipe spring is that, offshore they slacken off these tie points and the tie point moves 10 mil, 50 mil. Our view is that, well, look, the pipe was in that position, so they should be able to pull the tie point back into that position using turfers or whatever. And they wouldn't be applying any more stress on that pipe than what it was in at the time that we surveyed it. So springing tie points is an easy answer. Temperature, difficult one, depending on where this goes as the plant cools down.
I guess what we're really discussing is the limits of immediately importing tie point data in and using it as a design position, an installation position. And
Yes.
Offshore, I can imagine that we're dealing mainly with pressure and corrosion and other issues, but not really a temperature expansion issue. Pipe stresses are probably from other conditions. I haven't done a lot of offshore piping, so I can't really speak to that. But I know onshore, if you're trying to tie in a steam line or something there, you're trying to add on to a moving pipe system, and you're installing it in a cold position, and it's going to become but you're measuring this location in a hot position. You've got to do some analysis to make adjustments. And then once you've gotten a new position, maybe even a slight angle change, then that becomes the true locus of the position orientation and out vector of your tie point. But to have a tool rather than no tool at all is certainly got to be a plus. I've been in the position of trying to determine from a scan where a nozzle is, and it's just absolute nightmare. You're guessing from ISOs. You have scan data. You've got to somehow build a model around it. You're looking at construction conditions during shutdown, and it's going to heat up. It's really kind of requires some analysis, but you must know where it is today, and then see if you could predict that with your design model, and then it's still a little bit of an art form.
Well, yeah, to a certain extent, but some of the offshore engineers who've come onshore from projects where we've been involved in, and they've just said, this is amazing. that when in the early part of this century, you know, Shell basically told everybody in the North Sea dimensional control every project, because in the old days they were predicting a shutdown of, say, let's say 3 weeks. And because of all the things they didn't realize, wrong dimensions, everything clashes, they were running into 6 and 8 weeks. And then suddenly, when they started doing our stuff with it, instead of the 3 week shutdown, it was being completed in two. In terms of tie points moving, that Total Abu Kush one, where we saved the full field shutdown took it from 3 months to 3 weeks. There was a problem in our model. We had not been given the true models of one of the new flanges, new valves. And the body of the valve was sticking out considerably. And we had a new pipeline going way past it. And it was actually clashing. But I was speaking to the installation foreman, and you wouldn't believe how close he'd managed to get the spool to tie in, even with this massive clash. I think you'd be surprised about what the installation teams can achieve if you give them a chance, in that it's 5-10 mil, considering what they've had to put up with in the past, and still manage to make it fit. You know, loosen off all the pipe supports so you can pull the flange closer, etc. You know, we always say when you're doing a closing spool on a full new installation of pipe work, don't tighten up your pipe supports. Get the pipe work all fitted and then tighten up your pipe supports to try and accommodate exactly what you're speaking about.
Yeah,
You're gonna have to go trace back to the nearest anchor and try to predict what the thermal growth is going to be at the point where at the flange that you're, so.
yeah, that's right. I mean, you use whatever tricks you got, but any indication of position is better than no indication at all physically where it is in the plant. So it's not a disapproval. It's just a recognition that further analysis would be needed to compare the measured position and the construction position to get that right. But you have to start with real measured data. The other thing, the nice thing about flanges is that they're really, really easy to determine locales of pipe. And I wonder if there's any discussion of using this kind of analysis tool to look at construction damage, from weather events, hurricanes, tornadoes, things like that. Any indication of people wanting to say, we think that pipe is moved. Can you go make a measurement? And it seems like a flange. You don't have to say tie point, but a flange is a good loci to try to make a measurement from. Any interest in the field to look at storm damage or anything like that?
Yeah, yes, we've done. I mean, last year we completed a job in Saudi where I forget what type of plant it is, but basically it had massive damage. The walls of the vessel were all bent, everything like that. So we were able to analyze that and tell them what was wrong. The steelwork nearby was bent as well. So yes, short answer, yes, we've done a lot of that. I think a funny story is we were trying to sell laser scanning of a whole plant, chemical plant in Rayon near Bangkok, and went in, demo to engineering manager, says, "Oh, that's very nice, but we don't really need that." 3 weeks later, they had a huge explosion and fire in that plant, and the guy straight on, can you do laser scanning and tell us what the plant should be like? We said, well, I'm sorry, it's a bit late now. So no, for record purposes, yes. We're also in partnership with a new Australian company, and what they do is they're taking the photography from the laser scanning and they're doing corrosion analysis. Now, they've got algorithms now which, by looking at bubbles in pipework, they're able to tell whether there's a corrosion problem under that bubble or a significant corrosion problem under that bubble by analyzing the scan data and the imagery. And then instead of putting huge teams of NDT inspectors onto your plant every year to monitor, they're able to direct NDT teams with a confidence level of about 85% onto the real corrosion problems in your plant. So never mind having a record which you can use for engineering purposes, you can also have a record which is suitable for corrosion monitoring.
That's quite unique.
Yeah, that company is called Abyss, and BP in Houston has already approved their system for all of their infrastructure. That'll be BP Amoco, I guess. All of the infrastructure in the Gulf, and they're in the process of getting BP, not UK, to approve it as well, which should be straightforward. And they're also doing tests for Shell in Qatar. I just say everybody's got my email. If they want to pop me, if they have any other thoughts or anything, I'll be happy to respond to them. Brilliant.
Thank you.
All right.
Very, very interesting talk. Very interesting tool.
Thank you very much, everyone. Thanks for attending.
Okay.
Thank you much. Thank you
Thanks,
very
Douglas.
much, everybody, and enjoy your evening or afternoon.